Hey, what's up guys? My name is Cherno. Welcome to episode 80 of game programming. We have hit 80 episodes, so that deserves a like right there. But freaking episode 80. That's quite a lot of episodes. So I'm happy that you guys stuck with me thus far. If you have, of course, you haven't just randomly clicked on it. And hopefully we'll be wrapping up the game in less than another 80 episodes, but we'll see. Anyway, we're going to talk about better particle animation essentially today. So we're going to be adding a Z variable to this. So we've got X, we've got Y. We're going to talk about Z today. So let's just take a look quickly at what we have right now. So if we just launch a particle, they kind of just explode everywhere, and you can see that it doesn't really feel like gravity is involved at all in this. And we want to basically add this concept of gravity. We want to simulate some really basic physics here. So how are we going to do that? Well, we're going to add a Z modifier here, like a Z direction essentially for it to go. Now, the way that this is currently laid out is fine, but I'm going to change that. So what I'm going to do is I'm actually going to keep the XXYY here, and then I'm just going to make another line for protected double XA and YA, okay? And the reason for that is I'm now going to add ZZ and ZA. And it was just becoming a pretty big line, and it was kind of unorganized, so I like to organize things, at least in programming. So I split it up into two lines here, okay? So what do we do with Z? Currently we got this dot YA equal to random.next Gaussian. We're gonna set this dot ZZ equal to, let's just set it to 2.0 right now, okay? And we'll probably set it to a random value as soon as I demonstrate this. So what we want to do now, the idea is, of course, to simulate Z, the best way to do that is we want to add some kind of gravity. Now, if we just launch our game right now, even though it is technically top down, the way that people are going to see gravity, at least for now, is going to be downwards, okay? So what we want to do is we want to kind of move these particles down. Now, the first thing you're going to ask is, okay, well, this is a 2D game. Okay, this is a 2D game. How are we going to move them down? Well, how would you move them down? You would move them in the positive Y direction, wouldn't you? Okay, so because of that, because we want to move them in the positive Y direction here, what we're going to do is actually go over here and into our render, and we're going to actually subtract, of course, cast to an integer first, ZZ from our YY, okay? And what that's going to do is move it downwards for us. So the way that we're actually going to do that is over here in this dot XX and this dot YY, we add XA and YA to it, which is basically the amount of animation we want to add to it. We're going to do the exact same for Z, so this dot ZZ plus equals ZA, okay? And ZA isn't currently set to anything, okay? That's one thing that you should probably have noticed. And that's absolutely fine, okay? So a lot of questions are circulating in your mind. First of all, why are we subtracting ZZ and not adding ZZ? And the second question is, what is going on with ZA? We'll talk about that in a minute. But if we just preview this as it is right now, you can see that our particles don't change at all, which is good, okay? And the reason they don't change is, well, there's a lot of reasons. Primarily because, of course, ZZ is just statically equal to 2, so all we're doing is we're simply subtracting 2 from our Y rendering location. But what we're going to do now is actually animate this value of ZA. What we're going to do is for XA, we're going to subtract, for ZA, we're going to subtract 0.1 from it every frame, okay? Rather not frame, every update, okay, or every tick. We're going to subtract 0.1. So what that's going to do, if I just bring up old paint.net here, old and trusty paint.net, what's going to happen is currently ZA is equal to 0, okay? That's the default value. If I grab a paintbrush here, this is probably not wide enough. That's probably good. Okay, so if I grab this paintbrush here and I'll show you what I mean, if we're at 0, right? If we're subtracting 0 from Y, or in this case, I guess we're subtracting 2 from Y. But anyway, if ZA is 0, we're sort of going like that. Now, as soon as ZA starts to decrease, so does our line here. And of course, since we're subtracting 0.1, at this point in time, our rate might be 0.1 because we've just subtracted it 1 frame. Now next frame, it'll be 0.2. And by frame, I really mean update, sorry. And so on. So it's actually going to, not really exponentially, but the rate at which it decreases is actually going to increase. So we might have 0.3 here, and eventually we'll have something like 1, and we'll keep going further and further, okay? So that's sort of how this whole thing works. So what we're doing is instead of just going, oh, okay, let's just make a linear, we're actually creating a curve here, and that's just gonna look a lot better, okay? So I hope you guys enjoy that, the 80 episode special, that little diagram there. So let's take a look at what this looks like now. If we launch this and run this, oh, check that out. We've got some kind of sick gravity simulation going here. Now, just to show you guys what it would be like if it was linear, if we just set this equal to 0.4, for example, and run this, that's probably not even good enough. Make sure it's negative, first of all, and then let's set it to about 1.4. You can see we just get this kind of linear, like, it doesn't look nice because these particles are just going down a linear path. They don't have any anything interesting about them. They're boring, okay? But if we actually do subtract 0.1, we're actually changing the rate at which it goes down every update. And we get something a lot more interesting and just more aesthetically pleasing. And you can see that the speed at which they go down sort of increases the further that they go. So that's a really cool thing that we just added. What we're going to talk about next is simulating a floor. So we want to simulate a floor. Now the reason is this looks just kind of really cool, first of all, but kind of unrealistic, right? Because what's happening is it's just falling off the screen as if it's not even part of the level. It just looks cool, but this would be cool for a platform or something, a platformer, but it just doesn't really work for a top-down game, especially because it's going all over the walls and it just doesn't really fit in, although it is very cool, okay? That's what it has going for it. Now to change that, we're gonna add a floor, okay? Now think about it, if ZZ is our like virtual Z coordinate, so in other words, X is horizontal, of course, Y is vertical for us, and Z is kind of our depth here. If you look at it from a top down, Z is our depth. Now, if we're simulating depth here, the floor should be at around Z equals 0, right? So let's just say that the floor is at Z equals 0, and the more we increase Z, the closer it is to the camera, and the more we decrease it, the further it is away from the camera. So kind of like OpenGL here. Because that's sort of closer to the camera is actually a positive Z direction. Although in my opinion, it should probably be the other way around, where Z, the further you push it back in Z, the bigger the number is. But anyway, so basically what we want to do now is create a floor, a virtual floor. And to do that, we're going to say that, okay, well, if Z equals 0, then our particles are on the floor. So let's make them bounce. This is going to be cool. So right over here, we'll simply say that if ZZ, if this does ZZ, and really there's no need to put this here because there is no ZZ local variable here. If ZZ is a less than 0 or equal to 0, we'll just make it less than 0. It doesn't really matter. Because it's probably never going to be equal to 0 because of this subtraction going on here. If ZZ is equal to 0, first of all, we don't want particles to go beneath the floor. So let's make sure that they can't be less than 0 by setting them equal to 0. If they are less than 0. And the other thing that we'll do is simply change the direction of them. Okay? That's very simple to do. Now, and we'll probably slow them down a heap. Now, if this is going down, okay, let me just explain this thing as well. This is, of course, becoming negative. ZA starts at the default value of 0. As we subtract things, ZA is a negative value, so it becomes negative 0.1, then next update it becomes negative 0.2, then negative 0.3, etc. because we're subtracting 0.1 every update. Now, clearly, because YY is a positive value here, and we're subtracting ZZ, which is a negative value, okay, since of course ZZ is actually plus equals ZA, which means that every tick, every update, where in this case, we're actually adding negative 0.1 to it. Then next update, we'll add negative 0.2, negative 0.3, 0.4, etc. This will be negative essentially. And because we're going negative, negative, we're adding, okay? So eventually we'll be doing, instead of going y minus negative 1, for example, we're going y plus negative 1, because of course, if you subtract a negative number, that's going to be an addition. So that's why we do put a negative here, not a positive, because of course, if you think logically, this should be a positive. If ZZ was a positive number and we wanted to go down, we'd add a positive, but because it's negative, we got to chuck in a negative. So of course, back to this floor thing. If ZZ is less than 0, let's make sure that it doesn't go beneath the floor, and let's reverse its direction. And we can do that really simply, just by saying ZA times equals negative 1. How do we make a negative number positive? We multiply it by negative 1. How do we make a positive number negative? We multiply it by negative 1. Same thing, right? So this is some really basic maths here. Now, the idea though is that when something bounces off the floor, it's pretty rare that it actually bounces off with the same velocity. It usually slows down. But let's take a look at what this looks like anyway, just for fun. You can see that as soon as I hit the ground, which is very fast, obviously, because ZZ is only equal to 2. If we set this to like something like 20, then they'll be a lot higher. But you can see that bounce is really pronounced now. Yeah. But the problem here is, let me just quickly fix one thing. This in Wizard Projectile, the life of this is set to 44 right now. I'm going to set it to 440 just so we can see this without it disappearing. Let's go back into particle. Okay, so if we look at this, you can see you can see them bouncing, and it's really pronounced here, right? But the thing is, they bounce up with the same velocity that they bounce down. That's a bit of a problem for us, isn't it? We kind of want them to slow down. So what we'll do is, instead of multiplying it by negative 1, we can multiply it by something that's less than 1. So something that's between 0 and negative 1. So 0.5 might be a good place to start, right in the middle. So if we take a look at this, what we should see is they slow down, and they slow down really quickly. In fact, you can see that after 2 bounces, they basically just start sliding. Maybe set it to something like 0.8. And this is where different materials come in. If these were wood particles, we might want them to bounce a bit. If they were stone particles, we really might want them not to, okay? So that's a really cool way to do it. Now, the thing is, we're slowing down Z now, okay? So they bounce, you can see that their bounces get less and less high. That's cool, but you can see they really do scatter a lot on the X and the Y axis. That's probably not a good thing, because we kind of want them to slow down a bit. And of course, we can do that just as we were before. With every bounce, let's halve the rate at which they go across the x-axis, and let's halve the rate at which they go across the y-axis. Now, you could divide equal this by 2, and really you'd get the same effect, but it's just better to use multiplication rather than division. That's just how I roll. Okay, so there we go. You can see that as they go there, they sort of stop here. And they kind of keep bouncing here. They will eventually stop. And you can see they stop around the time that they disappear. But that's pretty much how that works, okay? Very, very simple, very effective. This is probably too fast. If we put it to 0.2, they'll barely move at all, probably. Yeah, you see they kind of, as soon as they hit the ground, they kind of stop at that place and they stop bouncing. Maybe something like 0.4 might be fine. You can actually vary these, of course. You can maybe say, oh, okay, let's not make the move almost at all on the x-axis, but let's make the move a fair bit on the y-axis. So they'll kind of be spread out top down, as you can see there. They kind of stretch across the y-axis. I'm probably going to leave them at about 0.4. You guys can decide what you want for yourselves, but that looks pretty good, okay? Now, the only thing wrong about this is the life, but that's all right. Let's set this back to something like 0.5. And what you'll see is they'll actually stop after a while. And I really like that, to be honest. I kind of want the particles to stop here. And in fact, this life is fine, because after a while they'll disappear. But they've lived a good life. Now, what you might be thinking is, well, a lot of things are probably going through your head. First of all, this is awesome. I'm going to use this all the time. But the other thing is, what about this wall Cherno? They're going through the wall. That's not realistic at all. Now, we could use some relatively basic physics here to actually make them bounce off the wall. Or we could just say that, okay, if we hit a wall from the left side, let's not make sure that the x can be negative. Of course, this way, going left, is a negative x direction. So all we really need to do here is say, okay, well, if the wall is on the left side here, if the projectile travels this way and it hits the wall which is on the left side, then let's make sure that xa, which is the amount by which xx increases every tick, every update. Let's make sure that value can't be negative. So at the moment, xa is set to random not-next Gaussian, which gives it a massive distribution here, with a mean of 0.0. It gives it a pretty big distribution. Let's add about 2.0 to xa, and let's see what that looks like now. So now we've added 2.0, so it should essentially only go positive here. And you can see it does. There are still a few particles that don't really go. One that goes back here because random, again, as I said, random.next Gaussian doesn't exactly give you a value between what was it? -1 and 1. It doesn't really do that. So it gives you quite a random distribution, but you can see that's roughly what's happening. So maybe let's add about 2.5 to this or and as we do that, you can see that we are really bursting out of the wrong place here. So let's adjust for the x here by subtracting around 14 pixels. I don't know, that's just a number off the top of my head. See what that looks like, and that's almost good. Maybe about 12. Okay, that's looking pretty good. There are still the odd pixel that do go backwards, but in fact, I think that's probably a bit too much. Let's maybe drop this to about 1.8 or so. Let's check that out. Yeah, so I'm relatively happy with that distribution. Now let's account for these particles that are built behind the wall by saying that if this dot xa is actually less than 0, so in other words, if it can be negative, let's just set it equal to 0.1, so that they go forward a bit or right a bit, and that'll get rid of all those particles that were going behind, as you can see. So that looks pretty realistic now, apart from the fact that, well, we're getting random particles and they are taking forever to disappear. But of course, they will slowly disappear, and when they do, it looks really cool. But let's quickly fix up one thing. First of all, the height at which they fall is 20 right now. That's cool. Let's maybe randomize it a bit. Let's set it equal to random not next float, and maybe add about 2.0 or so. So let's take a look at that. Okay, there we go. So now this looks more like stone, right? Because this is what I was going for, by the way. This kind of looks more like stone, because what's happening here is, well, we are hitting essentially a stone wall, and this kind of looks like stone. It doesn't bounce much, doesn't move much, it just kind of crumples on us. If you really wanted it to crumple, you could probably decrease this even more, but I'll probably set it to about 0.7, so we get a little bit of bouncing going on. And you can see that's probably a bit too much. 5.5 maybe. Check that out. That looks really good. I'm really happy with what that looks like. So that's great. So let's go back to our wizard projectile class real quick. Set this back to 44 and see what it looks like with quick disappearance. And look at that, wonderful. So that is what our particles look like right now. There are a few things I wanted to mention since it is episode 80, and that's well, calls for a few announcements. First of all, what you're seeing right now is the game that I made during the 27th LD competition, Ludum Dare. And as you can see, the graphics look really nice. Now that's because I made them in After Effects, and of course I did make them during the competition. If you watch my live stream, you can see that. And in fact, if you check out the time lapse, you can see me roughly making them as well. I'm probably going to make those kind of sprites for this game, okay? Because I just want to step up this game graphically. Now, you guys have two options here. I could either show this as episodes of this series, in other words, show you guys me making these sprites, or I could just make them and, you know, basically replace them behind the scenes, so not showing them on video. If you want me to see, if you actually want to see me making these sprites, let me know in the comments, okay? And I'll be looking for like a top comment or the amount of comments essentially that say, yes, Cherno, show us how you make those sprites. Or of course, I could just make them in my own time and then show them next episode and focus on programming rather than asset creation. But if you do want to see them, let me know, and of course I will. I'll show you guys the process that goes behind doing that, and I'll make them in front of you guys. So I'll commentate and do everything as if it was a normal episode of game programming. But apart from that, guys, thank you for watching. Thank you for all of you who have stuck through 80 episodes of me talking about this and showing you guys how to make games. It's taught me a lot, and yeah, I'm really thankful that I have 16,500 plus people to teach how to make games. So yeah, thanks a lot, guys. Goodbye.